Hey, class. All right, we're already on the last lesson of notes for chapter 1, 1.5. Yes, there is no 1.4. I apologize for the missing number there, so hopefully that doesn't throw you off too much. Anyway, today we're going to really put this into context here and talk about loans and investments. Okay, so it's what I like about today's lesson. We're going to talk about borrowing money to like buy a house, buy a car, buy things. Investments also putting money away, for as we get jobs and we want to save for retirement, we want to have save for maybe a wedding, save to buy a car even, okay, where we don't have to take out a loan. So we're going to dive right into examples and show you how shifted geometric sequences actually can help you do this quite a bit. So here we go, first problem here. It says, Gwen's employer offers an investment plan that invests a portion of each paycheck before taxes are deducted. So she starts by investing U sub 0 equals $10. U sub n equals 1 plus 0.0475 divided by 52, wow, times the U sub n minus 1. You know how I like to have those switch, plus 10. So it says, wow, we got all these numbers, and we got to figure out kind of what these numbers represent. Because once you got these numbers figured out, this is so much easier to do. So it says the plan has a fixed interest rate of, notice how it's in decimal form. So if I move that decimal back, the interest rate is 4.57%. It's compounded. Oops, I didn't need to write the percent since it's there. Compounded, so I look at this number. 52 means there's 52 weeks in a year. So it's compounded weekly. Okay? Then she decides to contribute, so her adding amount, she decides to add $10 initially. And, whoops, I apologize. Initially is the starting amount. And then adds also $10 a week. So this is the initial, this is how much she adds each and every week. Kind of interesting. She starts with $10 and whatnot. That those are the same. All right, so now, part B says, what term of the sequence would show her balance after 2 years? So if I think about this, I'm looking for U sub 52 times a year times 2. I'm looking for U sub 104. What will be her balance at that time? So to answer this question, this is where the recursive form of the calculator helps a ton. So we'll go back to my y equals, and I'm going to start entering in all this stuff. So I know that U sub 0 stays the same, and I'm starting with $10. So I tend to always start with that bottom number. Then I go to the U sub n formula here, and now this is where it gets a little more complicated, or we got a lot more to type in here. So it says 1, I got to make sure it says plus 0.0475. So all that interest divided by 52. Close the parenthesis. Okay, so what's nice is you can kind of start to see it typed in here, and then I go plus 10. So I always like to just go in and re-edit it or hit delete where I need to. Don't hit clear, because then you got to retype in that U sub n minus 1. Again, second 7 for the U. The n is right here. You use your parentheses too. All right, so now I have it typed in my calculator. So if I go to my table, okay, yeah, I see how much money I have in there. So you can see after 1 week I have $10, 2 weeks I have, or after the first week, after I get my interest, I would get an interest of about a penny, okay? But now I have $20 and a penny, and I can start to see it grow. But instead of throwing one at a time, I can go to my table set and say, all right, after 104 weeks, go to my table. Now, what's interesting here is you do have to sit and kind of wait. My calculator goes pretty quick. I think your one on the computer will go faster than the handheld one. But it tells me, wow, after 2 years, just putting $10 away and getting interest, I'm at $1,101.48. Now, some of you might be saying, well, Mr. Parks, it says 0.5 up here. Again, look down here to get the exact penny. I get a little ticklish on that, okay? Got to watch the pennies, okay? Because every penny counts. Just check with a bank. So after 2 years, wow, over $1,000 just putting $10 away. Just imagine how much that could get after a long time. All right. Next problem talks about credit cards. Boy, I could give a 30-minute lecture just on credit cards alone. How credit cards are really awesome to have, but they can be very, very dangerous to have. Okay? What makes them really awesome is you don't have to have cash on your money in your account to buy things. The downside is if you do buy a bunch of things and you don't have the money and you don't pay the full balance of it, you're going to pay a lot more money, okay, than what you originally paid for. And people can get themselves in financial trouble with it. All right, so just to show you how it works. Okay, so it says, my Visa credit card bill indicates that I have a balance of $536. So I've charged a bunch of things, $536 worth. The card has an annual interest rate of 14.99%. Yeah, credit cards can be even like 20, 21, 22%. Really, really, really high. All right, so it says the minimum payment on this balance is $13. So here it says, what is the monthly interest rate? So to kind of keep this, I'm not going to put it as I'm going to write it just as a fraction. I need to change this and move it as a decimal, 0.1499. But since I'm doing it monthly, I have to divide it by 12. Keep it as that fraction, just like I did up in the top when it was the weekly one. Okay? So now, number 2 says, write a recursive rule to calculate the amount you owe after n months. So we start U sub n. I'm sorry, not U sub n, U sub 0. So U sub 0 is the starting amount. That's my balance. So I owe $536. Okay? So now, how it works is the recursive U sub n times U sub n minus 1. The bank charges you interest. So what happens is you'll have this 1 plus this monthly interest, this 0.1499 divided by 12. However, at the end of the month, you pay off the minimum balance of $13. Okay? So what we want to see is how much do you still owe after making, say, 12 payments. So each month you pay $13. Now here's the caveat, okay? You're not charging anything more on this card, okay? So you're just making the minimum payment and you decide, I'm not using the card anymore until I get it all paid off. That's kind of the kicker on this problem, okay? So we got to type it into our calculator. So go back to my y equals, okay? So this bottom number here is not $10, it's $536 because that's what the balance was. So now go up to that middle line, U sub n minus 1, see how I'm not changing it? So now it's going to be 1 plus 0.1499 divided by 12. So interest divided by 12, close the parenthesis. Okay? Then I subtract. So in this case, I'm not adding, I'm actually subtracting 13. Just want to use the cursor just to make sure there isn't anything past it. Okay? So it says, so now if I go to my table set, I'm going to start it back at 0. Okay? So now when I go to my table, what's nice is I can see, all right, here's how much was in there to start, 536. After 1 month, I still owe $529 and about 70 cents, as it would round to 70 cents. So I can keep on scrolling down. This is one when it's close to 0. I can start to see, wow, look at that. After 12 months, so U sub 12, okay, equals, I still owe $454, okay, and if I round it to the nearest penny, 93 cents. So that's the nice thing is it did round nicely, okay? So if I think about that, wow, I still owe a lot of money. I didn't reduce that by much, and I paid for a year. Here's the crazy part. If I still just keep on paying this minimum, you can see it's going down, and it's not going down very fast. In fact, I'm going to go to the table set, and I'm going to start it at 72, and I'm just making a guess, to be honest with you. I could be guessing wrong. So it's going to think. So let's see. Whoa, it did go negative pretty quickly. So my guess of 72 was way too big. So I'm going to scroll back up. What I'm trying to do is see where it finally first goes negative. So you can see here, okay, I've made 58 payments and I still owe $3.80. So once I've made the 59th payment, it's gone negative, which means I've overpaid by $9.15. So what I'm trying to figure out is how many months is it going to take for me to pay this off? So I'm just going to kind of note this. How many months to pay it off? Oh, you know what? Let me just see. Did it ask that? No, it didn't. Okay. So to figure this out, that's basically what we did. It takes 58 months. We go until it gets negative. So now I want to see how much I actually paid. So remember, okay, I was paying $13 a month. Okay? I actually did that for 58 months. Okay? Actually, I apologize. I lied right there. Mr. Bart's made a mistake. That should be 59. So this actually should be, sorry, I did that for 59 months. Okay? But on that last month, I overpaid. So what would usually happen is on that last payment, they would figure out. But you overpaid by $9.15. So this is how much I actually paid. This is how those credit card companies really make money. 13 times 59, but then I'm subtracting $9.15. Yeah, get that back. So that $536, I actually paid $757.85. Okay? So if I actually subtract the original $536 of what I charged, I had to pay that credit card company over $200 more just to be able to pay it without having the money. Oh man, paying just the minimum, yeah, that was a nice convenient, or it was convenient that I didn't have to pay much. However, it really cost me a lot of money in the long run. And that's where credit cards can be very, very dangerous. Okay? Honestly, I have one. I never carry a balance. Okay? They only charge you interest if you don't pay it off. If you pay it off at the end of the month, they don't charge you anything. Now, you might be saying, how do they make money? They still charge the people who own the businesses a percentage. So credit cards make money like crazy. All right, so let's take a look at this next problem. I think this is a great problem, again, just to see how loans and paying things off and buying large items when you don't have the money works. Okay, so like Mr. Bartz has done this for a few cars. Mr. Bartz usually doesn't have $18,000 sitting around to buy a car. But if he has good credit and can get approved, he can borrow money to buy it. So that's like what I've done on my last car. I borrowed money and we've been paying it off. So we still got about a year and a half to pay off one of our cars. So number 3 here, it says you plan to borrow $18,000 to purchase a new car. The bank charges interest at an annual rate of 3.6% compounded monthly. So that's going to be important. The bank informs you that a monthly payment of $330, or that with a monthly payment of $330, you will pay off this loan in 5 years. That's what they've told you. So, monthly interest. So just like we did, we take that percentage, got to move the decimal, so 0.036 divided by 12. So I just keep it as that, because that helps me write the recursive definition. So we start with u sub 0. How much money did I borrow? Mr. Bartz borrowed $18,000 for this car. So how does the loan work? Well, you have u sub n equals u sub n minus 1. So the bank makes the interest. So 1 plus this interest, this 0.036 divided by 12. Okay. However, I'm going to make monthly payments of $330 to help pay off the car. They told me I'm going to pay this car off in roughly 5 years, in about 60 months. So here it says find u sub 12 on your table in your calculator. How many payments have you made at this point, how much do you still owe on the car? So let's explore that for a second. So let's type this in our calculator. So again, this minimum value at the bottom is how much you're starting with. So in this case, I'm borrowing $18,000. So I go U sub n equals U sub n minus 1. So now I'm going to change all this. So 1 plus 0.036, dividing it by 12. We'll close parentheses. But I'm going to make a monthly payment of $330. Okay, so that's all fits in there nicely. Okay, so now if I go to my table set, I know I should probably start that. I might actually start it at 12. Actually, I'm going to start it at, well, not 120. Ooh, I got myself almost in trouble. Whoops. Delete, delete. Okay, I'm going to start it actually at 0. You can start it wherever you want. But I'm just doing that just because I want to see that it's actually, you can see it's going down rather steadily. But after 1 year, I still owe a decent amount on the car. Okay, so as we do this, okay, U sub 12 says that I still owe, I'm going to highlight it, I still owe $14,632.80 on the car. So I actually highlighted, I know it says 33, but it's actually a little bit less than that. So it says how many payments? I have so far made 12 payments of $330, okay? And I still owe $14,000, okay? So now, notice how here it says, okay, after 60, okay? So what I'm gonna do is I'm gonna go to my table set and I'm gonna go to 60 here, just kind of like they did here. Hit enter here and then go to my table. It's gonna think for a second, okay? And I'm actually gonna scroll up just a little bit so that you can see that this screen and my screen basically matches up, okay? So what does this U sub 60 negative 114, and this is the one thing that I want to highlight because I think there's a little mistake, because it really should say 32 mean, okay? Because I think when these notes were written, even the teacher made the mistake a little bit on that one. So what this means is at the 60th payment of $330, you overpaid by $114.32. Okay. All right, so now I think this is important to know, okay? How much will you actually pay for the car over the 5-year loan period? So if I think about this, just like we did on the front page, I kind of extended it. This was our monthly payment. So you were paying $330. We're going to times that by the number of payments, 60. This was the number of payments. So you had to make a total of 60 payments. However, we overpaid by $114.30. So I'm going to exit out of here and let's calculate this out. So 330, I paid $330 60 times minus 114.32. So that's how much I overpaid on the last payment. So for that car, I paid $19,685.68. Wow. Okay. So now, yeah, the car was originally $18,000. So how much interest will you pay over the course of the loan? Cross that out. Okay. So you take that number, $19,685.86, subtract the 18,000 from it. Some of you have already done this. Like Mr. Bartz, we already know this answer. I'll just show it on the calculator. So you had to pay $1,685.68. And yeah, Mr. Bartz even does that, because that's kind of the price if Mr. Bartz wants to have a nice new car, okay, for a period of time, how much he actually has to pay. All right, so hopefully those two examples will help you a little bit with the worksheet problems. Again, as I usually say, watch the video to help you if you get stuck anywhere, or just let me know and we can always try to hook up and do a Google Meet. All right, have a good day.